Okay, here we are. Today's a really good day, intermediate value theorem. You're going to need to know this without a doubt for the course as well as for the test as well as for the AP exam. And it starts out by saying this. Suppose f is continuous on a closed interval AB. What does that mean? What does it mean to be continuous? Stupid definition. I can draw without picking up the pencil, correct? Okay. So what I'm going to do is I'm going to draw a little graph here. I choose A, B. And the function is continuous, so it's got some point there and some point there. The function goes from A to B. Okay, so that's the premise. And let n be any number between f of A and f of B, where f of A is not equal to f of B. What does that mean? What is f of A and f of B? What does that look like on the graph? And those are the y values. So if this is A, this is f of A. And if this is B, then this is f of B. So it says n is between those two. So we'll volunteer Danny. Danny, you tell me n has to be between these two. You tell me where you want me to be, okay? I'm gonna move up, and you tell me when to stop to put in, okay? You want right here? And now we finish off the mean value or the intermediate value theorem. Then there exists C between A and B such that f of C is equal to n. Let's try to understand what we just wrote down. It says that there's a value C between A and B such that when I plug C in, I get an output of n. So if I follow this over, I get to a spot. Does that fall between A and B? It sure does. It sure does. We'll let somebody else pick a value here. Rachel, so Danny picked this red spot for n. You pick another spot for n. You tell me when to stop. Okay, so she chose way up there. All right, let's see if C falls between A and B. Good, good job. Nice. Condog, you choose a spot. You tell me when. Does C fall between A and B again? It always will if it's continuous. Okay? Now, here's kind of another way to really think about it, okay? Suppose that I've got a graph here, and I've got a value A and f of A, okay, right here. And I've got another value B, and I've got f of B. over here. Okay? Everybody okay with that? And I've got a value n. The question is, can I get from this point to this point without crossing the red line? It's a game. Do you think I can do it? I did it, right? Why is that illegal? Now it's not continuous. Shoot. Yeah. Now it's not a function either, is it? Yeah. It doesn't pass vertical line test anymore. Yeah. So you can see that if you're going to go from A to B, you've got to cross over every y value in between. If you're going to go from this value right here, this first y value, you want to go to the second y value, you got to cross over every single other y value in between. That's really what the intermediate value theorem says. We call it the IVT theorem for short, IVT. Okay, so let's try a couple practice problems. It says, explain why the function has a 0 over the given interval. What does it mean for a function to have a 0? What does that mean? That means if there's a certain number you can plug in that you're going to get 0. Okay, so here's what we're going to do. We're going to call this A, and we're going to call this B. So I have f of -2. I'm going to plug in -2 and see what I get. Anybody tell me what I get when I plug in -2? -2 cubed is -8, minus 2 is -10, plus 2 is -8, right? And then I have f of 1. What's f of 1? 4. So I start at -8 and I go to 4. So think about the graph here. We've got -2, -8, so somewhere down there. I've got 1/4 somewhere there. So if I'm going to go from here to here, do I have to cross over the x-axis? Yes. Yeah, you do. And why? The intermediate value theorem guarantees that. We've done our work. We've shown that there's a value below 0. We've shown that there's a value above 0. So the IVT says we've got to cross over every value in between. 3 times sine of x plus 1. Let's see what happens. We'll call this A. We'll call this B. F of 0. What's the sine of 0? Ooh, we got to go back to this. So 0 is right here. What's that terminal point? What's the location of this coordinate? 1, 0 is sine the x value or y value? It's the y value. So the sine of 0 is 0 times 3 is plus 1, 1. So f of 0 is 1. Now I have f of 5 pi over 4. So 5 pi over 4, that's 225 degrees. Anybody know that terminal point? Good, so we have -3 roots of 2 then, over 2 plus 1. We should see if that's positive or negative, huh? I'm going to use my handy dandy calculator here, and I think it's negative. At -3 roots of 2, I'm going to add 1 to that guy. Whoop. What happened? What happened? There we go. We got a negative value. So does this have to cross over 0? Yeah. No big deal, right? We're going to pause. You're going to start on those problems, your assignment, before we move on to the next. Okay, pause and look back at this problem then. It says verify that the IVT guarantees that there is a 0 in the interval -1, 2. Find the 0 by using a graphing calculator. So what we have is somewhere you have a value of -1 and 2, okay, x values, and we have a corresponding y value. So we don't know if the graph goes like this, or maybe the graph goes like this. We don't really know what's happening, but how could I guarantee that it has a 0? How could I do that? What do you think? Not 0, but plug in -1 and see if it's above or below the x-axis. If I plug in -1, I get 1 minus 1 plus 1, which is 1. So am I above or below the x-axis? I'm above. Now I'm going to try to plug in 2. Plug in 2, and you get 2 to the 4th, 16 minus 4 plus 1, and you get 13. Did I cross over? The intermediate value theorem does not apply. I don't have a value that crosses over 0. It says that there's supposed to be a 0. The IVT does not guarantee a 0. It might. The graph might look something like this. It might look like the green graph. But it doesn't for sure have to have a 0. Look at the next one. True or false? The next function is continuous over all real numbers. True or false? The next function is continuous over all real numbers. False. True or false? The next function is continuous over the interval. True. It's discontinuous at -2, but -2 does not lie in the interval, does it? Suppose that it said that the interval was from -5 to 5. Then we say the IVT does not apply because it's discontinuous at -2. But in this case, it's continuous over the interval, so we're good to go. We're going to see if this thing has a 0. So we try f of -1. I get -4 over, let's see, -1 plus 2 is 1 plus 3. So -4 plus 3 is -1. So I'm hoping that f of 2 would give me a positive value. That means it crossed over the x-axis. Okay? So I plug in 2, and I get -4 over 4 plus 3, or 2. So did it cross? It did. Let's use our graphing calculator to actually find where it crosses. I take my calculator and I type in this function, -4 divided by parentheses. Make sure you're using parentheses for the denominator, x plus 2. And we're going to subtract or add 3 to that. I'm going to zoom standard, and I'm hoping that I see this cross the x-axis. Does it appear to cross the x-axis? How do we find that spot? What do we press on our calculator? So I can calculate 0. Left bound, enter. Right bound, enter. I go above and below. I don't need to guess. It finds an x value of -2/3. Is -2/3 between -1 and 2? It sure is. Flip it over. This says verify the IVT applies to the indicated value of C and find C guaranteed by the theorem. This is a quadratic, correct? What it's saying is that if you look at the interval from -1 to 3, that at some time it has to have a height of 6. At some time it has to have a height of 6, and we want to know when that height occurs. Well, We're going to show that it happens, and then not only are we going to show it happens, we're actually going to find that value. So I'm going to do f of -1. Oh, sorry. What is f of -1? -2. What is f of 3? Nine plus 12 plus 1, 22. Very good. Is 6 between those two values? It is. So does it have to cross over 6? Yes, it does. The IVT says it has to have a value of 6. Notice we're not saying it has to have a value of 0. Does it have to cross over 0? Yeah, it does, because it goes from negative to positive. Does it have to cross over 30? No. But it has to cross over everything between -2 and 22, which includes 0 and 6. So we're going to find that. All we have to do is take the function x squared plus 4x plus 1 and set it equal to 6. Do you know how to solve that? What do we do? Subtract the 6 on over, got a -5. Does that factor? X plus 5, x minus 1. What are our solutions? 1 and -5. What the heck does that mean? If I plug in 1, I should get 6. If I plug in -5, I should get 6. But which one of these am I concerned about? Or am I concerned about both of them? I'm only concerned about one. Why? Exactly. C is 1. Next one's super easy. Why? What's that? It's not continuous where? It's not continuous at 3. Is 3 in the interval? It is. So IVT does not apply. Discontinuous. These two go pretty quick. This one, show that the following function is continuous. What are the 3 rules for continuity that we learned yesterday? Do you remember what the 3 rules were you learned for continuity yesterday? The limit exists. I'm going to put that for number 2. That's what I intended yesterday. I'm sorry. Limit x approaches a of f of x exists. Good. F of a exists. And what else? They're the same. The limit as x goes to a of f of x is equal to f of a. Very good. So I'm given a piecewise function here. I would like to be able to state whether or not it's actually continuous at an x value of 1. Notice what I have here. Well, I need to first show number 1. Does f of 1 exist? What is f of 1? It's 3. I'm going to check number 2. I need to check the limit. In order for the limit to exist, it has to be the same from the left as it is from the right. So if I want to check it from the left, what do I plug 1 into? That's from the left, correct? This is from the right. Well, what's -1 squared plus 4? I get 3. And then if I plug in 1 here, I get 1/2 times 1 plus 5/2, which is also 3. So does the limit exist? The limit is 3. Are those two the same? Yes, exactly. So f of 1 is the same as the limit as x approaches 1 of the function. And they both equal 3, so we are good to go. Last example, super easy. Prove that there is a number that is exactly 1 more than its cube. Talk with a friend. See if you can think of the number off the top. Did you come up with it? What are some perfect cubes? 8, 1, 8, 27. I mean, so if you cube 1, you get 1. If you cube 2, you get 8. If you cube 3, you get 27. Are any of these 1 more than its cube? No, they aren't. We're going to prove that there's a number that actually exists. Prove that there is a number x, that is 1 more than its cube. There is a number that is 1 more than its cube. Everybody agree with the statement here? So if I could solve that, then I found the number, haven't I? Or in other words, if I could show that this function has a 0, I've shown it. Can somebody give me a number that I could plug in and come up with a positive? 0. F of 0 is 1. Can somebody think of a number I would plug in where I would get a negative? Throw out a number. -1? We could try -1. -1 cubed is -1 minus -1 plus 1. Does that one work? No, we get 1. What did you say, Connor? Let's try -2. What's -2 cubed? -8 minus -2 plus 1. So if I go from 1 to -5, do I have to cross over 0? You sure do. And so the number that's exactly 1 more than its cube, it must be a number between 0 and -2. So the IVT says so. The intermediate value theorem says if I'm going to go from 1 to -5, I have to cross over everything in between. And so I must have a value between 0 and -2. Because I know you guys really just want to. I am going to find it. X cubed minus x plus 1. Does it cross between -2 and 0? It does. I find that 0. X is -1.32 is a number that's exactly 1 more than its cube. If you take -1.32 and you cube it, you can see that that is 1 more than its cube. Well, you know, I didn't round very far, but that's how it goes. So here we go.